For this next episode, I just wanted to preface this by saying this is not page 146 in your text. It is actually not an example from your text. For whatever reason, the instruction manual diverges pretty significantly from your textbook. But I actually really like this particular example because it does a great job of showing you exactly how many sub-modules there may be that go relate back to a main module. So here's the hierarchy chart. And as you can see, we have account update master file up here. And as you can see, we have 1, 2, 3, 4, 5, 6, 7 next line subroutines in our main line, right? And from there we have 1, 2, 3, 4, 5, 6 further divergences down into kind of ancillary subroutines. So is it possible we can have a master algorithm that has numerous subroutines that spreads and gives you numerous additional subroutines? Absolutely. And remember, there's no kind of upper limit to how many of these subordinate modules you might have in a program. Windows, the operating system, is essentially just a colossally big program, and there are hundreds of thousands of subordinate modules that belong, to the larger operating system there. And that, again, really, I think, helps demonstrate the reason why we take advantage of the idea of submodules. Because if everything in Windows was simply in a mainline algorithm, there would be absolutely positively no way to break that up, to have the next developer in the chain make a small change, to have the next developer in the chain add new functionality. There would be no team of individuals who would have any idea of where anything was just structurally with your operating system. So, the more we rely on subroutines, the more we rely on subordinate modules. They're synonymous with one another. The better off our code is, because again, we have, with a submodule, we have a module whose name will clearly define what its purpose is. So here, again, this is an example you do not have in your text. Initialize variable fields. There is no question that submodule only initialize variable fields. Read account transaction record. That's literally all it does, is read the transaction record. So if we, select current record, that's a submodule that only does that. Apply transaction to current record. That's a submodule that only does that. Now, what I wanted to do, I'm not going to step through this line by line necessarily. I don't think that really helps you further your understanding of submodules here. But if you look here at our solution algorithm, this is far more indicative of what a real dense with functionality program would do. So this here, update account master file, starts, essentially our program, right? So our program runs between here and here. That is fewer than 20 lines of code. But look at the robust functionality we get here. Because again, all of this is the functionality we get from these 20 lines. Now, clearly that can't be the case, right? Clearly, we are relying on those subordinate modules to go out and do all of this robust functionality for us. So here, just inside of our mainline algorithm, we have initialize variable fields, read account transaction record, read account master record, select current record, apply transaction to current record, write current record status, print report totals. Those all are subordinate modules, right? So we have initialize variable fields here. We have read account transaction record here. We have read account master record. We have select current record. We have apply transaction to current record. Keep going. We have apply withdrawal transaction. We have apply interest transaction. We have write current record. We have print error report. We have print totals. And wait a minute, where are all these other modules coming from, right? We didn't see apply interest. We didn't see write. Actually, we did see write current record, but we didn't see print error report. The only way that we can have these here is if from a subordinate module we call other subordinate modules. So this one here, apply transaction to current record. This one is the one that goes through and we have a really robust set of actions that apply transaction to current record essentially initiates. So this one here, apply transaction, is really kind of a driver for a host of other actions. So under the umbrella of apply transaction, we read account, we apply deposit, we apply withdrawal, we apply interest, we print an error report if one happens to be there, and we read account transaction record. So if I scroll down to, I just need the name of that again, apply transaction to current record. We have essentially here a case structure, right? And each one of these actions really is a call out to another subordinate module. So in no way, shape, or form, this is, and again, you don't have this example in your text. This is my favorite example because of just how dense it is. But at the end of the day, it doesn't really matter what all the code herein is doing. The most important aspect of what this particular program module is doing is really just showing you how, look at all this additional functionality we're getting here. Look at all of these subordinate modules that we can string together so that in, 20 or so lines of code here, we can have a really dense, a really robust interaction and still have these small, single-purpose subroutines that get a very specific job done and help us clean up our code so that it's easier for the next developer in the chain to understand the scale and the scope of what's happening here.